A pleasant afternoon, one and all. The third session to be held is on the topic Electronics for IoT, IoT languages and its tools by Dr. Sharat Sinha from IIT Goa. I request Soumya to introduce our resource person to the gathering.
Good afternoon to everyone. It's my immense pleasure to introduce our research person, Dr. Sharat Sinha. Dr. Sharat Sinha is an associate professor of computer science and engineering with the Indian Institute of Technology, Goa. Sir has received PhD in computer science and engineering from NTU Singapore in the year 2014. Sir has received Best Paper Award at ICCAD 2017 and 2022, IEEE Indicon 2022, and the Best Paper Award nomination at CASES 2018 and FCCM at 2019. Sir received the Bachelor of Technology degree in Electronics and Communication Engineering from Cochin University of Science and Technology, India in 2007. Sir's research and teaching interests are in computer architecture, embedded systems, and reconfigurable computing. And Sir's achievements are many more. Thank you.
Thank you, Soumya. I would like to request S.G. Golgi sir to welcome Dr. Sharat Sinha. Thank you, sir.
Electronics for the Internet of Things involves the integration of sensors, actuators, and communication modules into devices to enable them to collect and exchange data. These electronic components form the foundation for smart and interconnected systems, allowing devices to communicate with each other and the cloud. Today, to enlighten us about electronics for IoT, IoT languages and its tools, we would like to invite Dr. Sharat Sinha, IIT Goa.
Hello. Yes, I am correct. But I think if I can use that, I will use the podium. Okay. Good afternoon, everyone. First of all, let me thank Professor Golagi for inviting me here. I have been interacting with him for the last 2 months or maybe 3 months regarding this FDP. I was surprised that somebody from this region approached me for an FDP talk here. But then at IIT Goa, we always reach out to colleges. In Goa, we have reached out to many colleges. This is the first time where some of our faculty members are delivering talk in nearby colleges which border Goa and Karnataka. So, so thanks everyone, and this is after lunchtime, so you may feel sleepy. I will try to keep the talk interesting. Some of the contents or parts of this talk may be a little high level, some may be a little low level, depending upon where your interests lie. I would suggest you try to understand maybe 10 or 20% of the talk. If you can understand 10-20% and use that in your studies or in your work, that would be very helpful. Okay, so the topic for this talk is electronics for IoT languages and its tools. What I will do is I will take you through a very short introduction of IoT, which you already had, I believe, in the morning session. Okay, we will look at IoT as a platform. We will look at IoT systems as computing devices. We will look at IoT's challenges. Okay, and then at the end we will come to the frameworks being the languages and the web stack which are used to implement IoT systems. So my talk is not about, you know, a sensor A does this, sensor B does this, and we put them together and this is how we combine the code. That's not the objective of my talk. The objective of my talk is that if you listen to what I am presenting, you go back with some ideas, with some thoughts. Implementation is what I cover towards the end, and then you can implement. But being engineering faculty members or students, what is important is that you develop some critical thinking skills, that you are able to analyze a given problem and choose or propose a solution for that problem. Okay, because there are many solutions to a problem, and sometimes all of them are correct. There's no perfect solution. In the industry, I have worked in the industry before I went for my PhD. The thing that matters is that your solution should meet the requirements. So as long as your solution meets the requirement, your solution is fine. It doesn't have to be the best solution. Okay. Huh? Sorry. Okay. Okay, so this is the outline of my talk. I'll cover a bit of background on IoT and IoT devices. Then we will take a look at IoT architecture and scope. Then we will talk about some development challenges, which includes both computer science and electronics related challenges. We'll look at a little bit of analytics in IoT. In the program for this FDP, you have dedicated sessions for analytics in IoT devices, but I will talk about more from the challenges point of view, or more from the critical thinking point of view than from the implementation point of view. Then we will talk a little bit about batteries, which is a very critical component in IoT systems. and then bit about programming languages and software frameworks and stacks. While we go through this, I will touch upon software frameworks and stacks as and when necessary so that you understand how they are used to build an IoT system. Okay. Some of the things in the beginning you may have already gone through that in the previous sessions, but just for setting the stage. So, IoT, as you know, stands for Internet of Things. You can compare this with the usual concept of internet. The usual concept of internet is it's a network that allows you to exchange information, whether you are using a mobile internet or desktop based internet or laptop internet. Similarly, in Internet of Things, the devices or physical objects talk to each other, okay, and perform some action. So, in order to talk to each other, they have to acquire some information which comes from sensors, and then in order to perform some action, they must be using some actuators to carry out the necessary task. But it is not always necessary that there should be an actuator in an IoT system. Okay, an actuator meaning a mechanical actuator. Okay, a lot of IoT projects, if you look at them, they have a sensor front end to acquire some information, but then at the end, we are more interested in analyzing that information. And most of the web based tools or platforms which you will try for IoT implementation will stop at that. You will not get into actuation. Okay. Okay. So let me not show that slide. So since you have had already introduction to IoT, can you tell me which was the first IoT device in the world? Okay. So the first IoT device in the world was an internet connected vending machine, which was launched in the computer science department of Carnegie Mellon University in 1982. Okay. The history behind this is that faculty members and students were sitting in the department. They used to spend their nights working in the department. They used to get hungry at night or thirsty. So, what would they do? There was a vending machine in the department where they would go, take a bottle of Coke or whatever, or a cup of coffee, come back to the department. Now, going to the vending machine and coming back would take time. It would also disturb their chain of thoughts if they are doing some research work. So, they thought that let's build something which would allow us to monitor the storage in the vending machine while sitting in the lab. So, they built that vending machine which was connected to their LAN network, and they could look at the status of the vending machine while in their lab office, and then accordingly go there to pick a bottle of Coke or a cup of coffee and come back. Otherwise, they would not go there until the vending machine is filled back again. Okay, so this is the first device or appliance that is considered to be connected to the internet. It was built by four people, and if you can look at them, their contributions have been in the areas of server software, documentation and user software, some hardware, electronics hardware, and some human computer interface, basically on the vending machine. These days, if you have seen vending machines, there are various kinds of vending machines. Some vending machines are very smart, where you can even make payments while using a payment terminal on the vending machine itself. Some vending machines are you have to put a coin or a rupee note, and it will give you something. So, so these are all manifestations of this initial machine. Okay. So, as far as the architecture of IoT is concerned, it's very basic concept. You have an IoT device which is a sender or a receiver. You have some communication infrastructure which will be some sort of gateway, routers, etc. And then you can have some IoT device on the other end which will act as an actuator or receiver, or you can do some cloud based computing where you can look at some analytics, or based on what is done in the cloud, you can do further actuation and all. So it's extremely simple. And if you look at the IoT protocols, which I think was covered earlier today, most of the protocols are intended for establishing this kind of communication between IoT devices. Okay. So let's look at some IoT devices. That is where electronics and software or computing lies. Okay. So in this presentation, when I talk about IoT devices, I will refer to devices which are at the edge. So I'm not going to talk about the communication infrastructure. I'm not going to talk about what is done in the cloud. I'm only focused on the devices at the edge, essentially devices which do some sensing and send some data. Okay. That is also, one of the most commonly accepted definition of IoT devices. And because of this reason, these devices are much less powerful than a conventional CPU or a GPU. So if you look at the laptop that you may be having or desktop PC that you may be having, the processor in those devices are much more powerful than the microprocessor that you would see in an IoT device. Okay. So here is one example of an IoT device. It was never launched in India. This was launched by Amazon in Europe, and subsequently, after a few years, it was also withdrawn by Amazon from the market. So this is a deliver it to you. Okay, so this was the concept. You didn't have to log into a web portal like we do currently here, and then place an order, make payments for it, and then it will come to you. No, not like that. You just press the button at your home. It's an internet connected button, and you will get the Rin or Vim or Pepsi, whatever you want to replace here, at your home. Okay. This on the right hand side is the board of this dash Amazon dash button. Okay. Here, anyway, here on the left hand side of this blue PCB, you will see there is a microprocessor, and there is also a Wi-Fi chip. Okay, microprocessor or a microcontroller. So this would connect to your home Wi-Fi when you press the button. Now, because this button has been issued to you by Amazon, Amazon understands that this button with a given ID belongs to customer X. Okay, and then Amazon, you can maintain some Amazon balance. So when you press here, the information that Amazon needs to fulfill the order is all there with Amazon. Who the customer is, what is the address of the customer, how much money the customer has in balance with Amazon, and what is the order every press will lead to. Okay, so say every press means you will get 10 packets of say Rin, okay, or Vim, and then they will deliver it. So this was very successful. They sold about 4 million of these these buttons in Europe for about 4 years. And then after that, they had to withdraw this from the market. Can you tell me why? Can you make a guess? So there is nothing wrong with the electronics. There is nothing wrong with the computation here. There is nothing wrong with the business model. But European countries are very particular about personal data protection, and they're also very particular about how their data is used for business. Okay. So some companies filed a complaint that this is at least what is reported in the press. The real story may be something else, but some companies filed a complaint that Amazon is capturing user information and their pattern, like how many times you press, how often you press, all of that can be captured by Amazon. So it's like profiling the customer. Okay, It's like trying to understand how the customer behaves, how much RIN they sell, sorry, they buy, how often they buy, etc., etc. So this kind of data that they were capturing is against the principles of fair market competition. Okay. So because of that, there was some court ruling, and as a result of which they had to withdraw this from the market. Okay. But as far as an IoT device goes, this was hugely successful. This is another one. This is an Amazon Echo. Most of you may have it. You might have seen it. And on the right hand side is the Echo's motherboard, the main circuit board, which is used in Amazon. These kind of diagrams that you see on the right hand side, you can go to a website called iFixit. This pointer is anyway, on the left hand bottom side is the source. Okay. So this website iFixit, you can go and you can see a tear downs of all kinds of devices. So you can see tear downs of iPhones, of iPads, of Samsung phones, of Amazon Echo, of Google, of Alexa, everything. And that is a good way to learn how these kind of IoT devices are actually there in the market. Okay, because you can see the full list of components that go on that board, and that helps you understand what kind of electronics is needed to build an IoT device like this. Okay, for example, that Amazon Echo Dot, it has a processor which is DM 3725. It is a digital media processor from Texas Instruments, and then it's based on ARM microprocessor architecture. In this case, it is Cortex A8, and it runs at 800 or 1000 megahertz frequency. There is one DSP in this Amazon Echo Dot. This comes from Texas Instruments C64X. There is no video acceleration on this Amazon Echo because you don't need video. It has a video port, dedicated input, dedicated output. There is some cache, there is some on-chip RAM. There are 4 USB ports, 4 SPI ports, 4 I2C ports, 4 UART ports. SPI, I2C, UART are ports that you typically use to interface with some sensors. Okay, your Amazon Echo Dot listens to what you say, right? So there is some audio capture happening. Okay, even if you're not saying, it will capture some noise. So those audio sensors are connected to either SPI, I2C or UART ports depending on the kind of audio sensor. So this gives you an idea of that if you go and look at say Texas Instruments microcontroller list, okay, or ARM's microcontroller list, okay, or say NXP's or ST Microelectronics, they all have, you go to their website, you will find a whole bunch of microcontrollers and microprocessors. Okay, you select the IoT application domain, they will give you a bunch of microprocessors, microcontrollers. But then the question is, which one should you choose? As an engineer, you have to answer that question, that I have these 10 options, I will choose option number 5. Okay, then on what basis you will choose option number 5? So you have to look at the features that those microcontrollers, microprocessors provide, and then your requirements. You match the features with the requirements, and then you choose one of the microprocessor or microcontroller accordingly. Okay. Okay, so that was a little bit about devices. We'll come back to some more details later on. Then let's try to understand a little bit of IoT architecture. Okay, so this is a very complicated diagram of an IoT system. If you take up an IoT textbook, you will not find a diagram like this. Okay, this is an actual IoT business case diagram. Okay, this is related to smart energy meters or smart electrical meters that some electricity companies are uh, launching. Okay, this diagram tells you a lot about where your device, your smart IoT device sits in the overall infrastructure, the business infrastructure that is built around an IoT device, how that IoT device identifies you, how that IoT device helps an electricity company to monitor your usage, okay, or if you are tampering with the IoT device, that also can be monitored, okay. When they issue you an IoT device, there will be something here, some person here who will do the configuration of the device, okay. Just the way if you take Wi-Fi from Reliance or from BSNL, they give you a device, right? Then they send you a person who comes to your home, who configures the device, and then that device is linked to your account. Same way these devices are also linked, okay. And then there's a whole bunch of billing at the back end, so data that is collected from the smart meters coming from various users. Based on that information, there is some billing, there is some workload calculation, there is some energy distribution calculation. All of that happens on the back end side. Your device is somewhere here, that's it, your tiny device. But then using that tiny device, you build all of these infrastructure, and that's your business case, okay. So sometimes it is good to look at some of these business case diagrams. This diagram is not very clear, but you can look at the link later on to understand how a simple device can lead to a business application, okay, and what role it plays in the overall business value that a particular company is proposing to launch in the market, okay. This is an example of a very simple sensing in IoT. So here we have some it is essentially some, let's say it is some soil, okay, uh, and then you have some sensor that understands the moisture in the soil. So soil moisture content, you can find such sensors on Amazon, on Flipkart, Robo.in, etc. That's connected to a microcontroller unit, okay. So the sensor also needs a sensor control circuit, so that when it senses, how often it senses, how it transmits the data that is captured, the MCU will process it, and then through some communication medium, that information will be transmitted, okay. In this case, it is showing that if you have done some sensing of the soil, and then that information is transmitted, so this is received here, that information is again processed for some need. The need here is to control, say, some robot, okay. So this robot is essentially meant for automated irrigation of a land parcel, okay. So if you have a lot of these sensors which give you information about the moisture content, and if moisture content is important for the crop that you are planning to grow on that piece of land, and you want the water to be distributed not manually but through some robotic mechanism, then you can use you can use that information to actuate a robot. And further, you can also use that information to transmit to some cloud based application where you can perform some data analytics, okay. So your sensing actuation combined here with, say, data analytics. I would not say big data analytics unless your scale of sensing is very large, okay. This is another example of actuation in IoT. uh, these are commercial devices, you can find them in the market today. So this is an IoT bulb, okay. This IoT bulb, if you use it in your house, you can control it using an app, okay, the lighting and everything. uh, you can also know the status, whether the light is on or off. You can also turn it on or off if you're not in the house, okay. So this bulb is basically internet connected, okay. These days you have air conditioners which you can control using Wi-Fi, correct. That is also an example of an IoT based application, okay. And this is another such example. Okay, so those are the some examples of IoT and architecture. So let's try to understand what is the scope of IoT. So IoT has a very broad scope, okay, and all of this scope plays a role in how you build an IoT device and what kind of regulatory requirements they have to fulfill, what kind of compliance requirements they have to fulfill. So home and building automation, I showed you an example of Lightify, the bulb earlier. In agriculture, I gave you example of soil moisture control and understanding. Asset tracking, I gave you the example of Amazon dash button. Okay, the RIN or the Vim or Pepsi, whatever item you want to think of, that is your asset, and you are tracking how much of that asset is with you in your house. Okay, there are also medical IoT devices, and then of course the smart city concept. So it will make use of a lot of IoT. Medical IoT devices are more complicated in the sense that they have to pass through some regulatory requirements, okay, depending on the kind of tasks that they do. For example, have you seen an insulin pump? Anybody? Insulin pump is used by people who have type 2 diabetes, so they will take an insulin shot before they have their meal. Okay, so these days you can find insulin pumps that whenever you make use of the pump, that information goes to an app. Okay, so you can track if you have missed your schedule, if you have not taken the insulin shot at the right time, all of that. Now that device has to communicate its usage to an app. If it does not communicate that information properly, then that means, what does that mean? That means that that particular requirement is not being fulfilled properly, and as a result the user could be at risk, right? Because the information that you see in the app is not recent and is not correct. Now if you are writing software for such an IoT application, there are guidelines on how you will develop software, on how you will verify that software, and how you will document that software. Okay, it is not it is not just about writing the code and documenting it. There are steps to be fulfilled from a regulatory point of view. So IoT for medical applications is more challenging than in this particular table, than the in this particular list, than the other four. But those kind of regulatory requirements you have to think about if your IoT device is targeting medical applications or it's targeting aerospace applications and things like that. Okay. Okay, so this was an IoT case study of a smart farming in Australia. I'll just show to you this. I don't know if I can play it. So anyway, this particular video you can also find on YouTube. This is taken from YouTube of a farm in Australia. That farm is spread on about 1,000 acres. Okay, it has many cows, horses, etc., etc. And there are very few people who manage this farm. So the farm is essentially managed using IoT devices. Okay, so the IoT devices give a status about the soil moisture content in various parts of the farm, the sunlight in various parts of the farm, the location of the animals on the farm. It also alerts the farm owner of about any trespassing or rain or anything. So there's a whole bunch of data that is captured here, which allows a person sitting in a small control room to manage the farm. Okay. Okay. Now, based on these applications and scope of IoT, let's try to understand some challenges in Internet of Things. Okay. So we'll begin from a higher level, then we'll drill down to the lowest level details. So what are the challenges? So we say that IoT has 5 C's associated with it. Okay, one is connectivity, which means that your IoT device has to be connected. But then if you have, for example, hundreds of IoT devices connecting to a network, there will be connectivity issues. Just the way you observe call drops in your mobile phones. Anybody here who has not observed a call drop? Call drop is if you are trying to make a call, it's just not going through. Or you are talking and then suddenly the call drops. All of you have observed, I believe, at some point or the other. Okay, so that happens because there are too many mobile phones trying to connect to the same cell tower at the same time. So that will be an issue when you have dense device deployments. If you're deploying thousands of IoT devices, connectivity will be an issue. And here, your knowledge of computer networks will play a very important role. Like somebody wrote there, Wireshark. Okay, that's a tool for network analysis. Uh, your knowledge of such tools will play tools and related protocols will play an important role in resolving network allocation challenges. Okay, then we have continuity. Now IoT devices are battery operated, okay, most of the time. So you would need a long battery life for the device to work for a longer period of time. Okay, which means there has to be some innovation, something new in terms of batteries. The communication protocols that are used for transmitting and receiving data, they also have to be low power consumption protocols. Okay, your Wi-Fi that we normally use is rich in consuming power. It consumes a lot of power. Okay, that is why in commercial deployments, Wi-Fi is not the protocol. So there are protocols LoRa, Sigfox, etc., which you might have already learned in the previous session, or in the next few sessions you will learn about those. These are low power protocols. They consume less power in transmitting information and in receiving information. Okay, the microprocessors or microcontrollers that run on these devices, they should also operate in low power mode. Okay, low power mode, all of you are familiar with. Your laptop, if you leave it on say for 5 minutes, what happens after that? And you don't do anything, screen goes off, right? Because there is a setting, display settings, where it is set to screen being turned off in order to protect or in order to preserve power. Okay, so your laptop has now gone into low power operation mode. Okay, so so such operation modes are essential for ensuring that these devices have higher connectivity. So there is a very interesting uh, thing with this connectivity issue. So you might have seen these CCTV cameras on traffic junctions. I don't know if it is there in Belgaum. It is there. Okay. How is it powered? Where does it get its power supply from? Huh? Solar panel. So what will happen if say if it rains continuously for 7 days? Huh? So solar supply is there, then you have backup. Okay, and then you assume that your camera will always be on. Okay, but that's not the case. Okay, your cameras will not be always on. There will be failures with respect to power supply, even if they are operating on solar power and having lithium ion batteries. Okay, and that is the reason why proliferation of such CCTV cameras is limited to only city limits, because in the city these can be controlled, right? Once you come to the highway, once you come to the village, once you come to the outskirts, there's no control over these things. Okay, so you cannot just deploy CCTV cameras because somebody may take away the CCTV camera itself. Okay, that happens. uh, so so continuity plays a very important role in IoTs. Then compliance. So these devices must also adhere to some radio standards and regulatory requirements. So these devices transmit information through some wireless medium. If you have a wireless router in your home, or even take your mobile phone, if you if you look at the back side of the mobile phone, if the details are exposed, or if you are able to remove the back cover, you will see it mentions something related to EMC standards, okay, or SAR absorption limits. These are regulatory requirements for any device that does some sort of transmission. This is electromagnetic compatibility, this is specific absorption rate. These tests are mandatory to ensure that the radiation that comes from these devices does not harm the people who are using those devices. Okay. Normally, when you build your IoT system as an hobby project and all, you don't worry about these things. But if you are building an IoT system which will go to the market, then you have to think about these things also. Okay. So there are ways to test this, and there are specific laboratories which do this testing. So all sorts of wireless devices, whether your mobile phone, which is also a wireless device, your Wi-Fi router, which is also a wireless device, okay, they have to follow these guidelines. Then coexistence, this is related to connectivity, because if you have hundreds to thousands or millions of IoT devices connecting together, the wireless radio channel will face some congestion. Okay, this again goes back to your courses like wireless communications and networks. So you should read those courses properly. You should understand the concepts that your professors teach in those courses properly to be able to answer these questions. Okay. And then the last point is cyber security, which has become important these days mainly, uh, where if you have built an IoT device, you have to ensure that it cannot be hacked. Okay, of course you cannot ensure that. If somebody wants to hack, they will hack. Okay, but then you have to make it very difficult to hack your device. Okay, so there are many people who put some CCTV cameras in their home, internet connected CCTV cameras, and not of very high quality, commercial grade, 5,000 6,000 rupees cameras that you can buy on Flipkart or Amazon. A lot of these cameras can be hacked over a network. Okay, so somebody else can see you through those cameras, and such cases have been reported. Okay, now for any company which operates some IoT device in some critical sector, they cannot allow such kind of hacking to happen. Okay, also, other than hacking, there is also this concept of over the air vulnerabilities. In simple terms, all of you have mobile phones. When your phone software is to be updated, how does it get updated? You get a push notification on your phone which says new software is available, install now or install later, right? And then you go download it on your phone and then you install it. So that software update has come over the network, over the air, not through some wired channel, not through some LAN cable. It came over the wireless channel. So if those updates are corrupted, or if those updates contain malware, then your phone can stop functioning. Okay. So if the update is to be done for some industrial IoT system, then uh, then how the update is carried out, what is the OTA process, what is the rollback mechanism, fallback mechanism, etc., etc. All of those things you have to think about for your IoT device that you're working on. Okay, so these 5 C's here are important considerations when designing IoT, and you can see that there is electronics here. EMC is antenna related, SAR is antenna related. There is battery, electronics, wireless communications, LoRa, Sigfox, etc. connectivity here, low power operating modes, which is for your microprocessor or microcontroller, as well as your operating system if there is any OS there, and then how you build system software. This is part of system software or firmware when we talk about OTA issues. So all of these things come together to make a good system. Okay. So so in terms of challenges, we can relate challenges to those 5 C's. So you have to think about what kind of operating system will go on your IoT device. So one example is say Ubuntu IoT. You have to make selection of gateways, whether it is Bluetooth, Wi-Fi, Zigbee, etc. You have to decide on the IoT platform, whether you will build your own or buy. Okay, it is very easy to buy IoT platforms. There are many vendors: NXP, ST Microelectronics, Texas Instruments. All these companies sell IoT platforms. Okay, you go to their website and look for application domain being IoT. You will find it. Okay, then you take that platform and you build an application on it. Okay, application meaning software. Okay, then there is issue of testing, because all of you would have done some amount of electronics testing, testing whether a circuit works or not, testing whether a piece of software or program works or not. But when we take the same exercise and we try to do it for a system that comprises of say tens or hundreds of IoT devices, it becomes much more challenging. Okay, then security, obviously, that we discussed earlier, and then user centric design. So for IoT devices which are targeted at commercial users like you and me, they have to be very easy to use. You think of Alexa, you think of Amazon Echo Dot, it's very easy. You just speak and the magic happens, right? You don't have to do anything. You compare that with your laptop. If you want to prepare a document in Microsoft Word, you have to open Microsoft Word, you have to open a new document, you have to choose the font, you have to choose the font size, you have to do X, Y, Z before you can type, right? So people who are comfortable with IT, they can do that. But people like my grandparents, perhaps your grandparents as well, they will not be able to do that. But think of Amazon Echo Dot. You press and the magic happens. Anybody can do that. You don't need any knowledge of electronics or IT to make that system usable. So these are also some points that you have to think about when you are designing IoT. Okay. Okay. So far so good. Any questions? You should ask some questions, or I will ask you some questions. Okay. So what we have seen so far is the very broad higher level view of what is an IoT device, how they function, what are the challenges, what things you have to think about beyond assembling like sensors connected to this pin and that pin of a microprocessor and writing some simple code. That is okay. That is okay for a lab project, okay, or for a lab exercise. But if you have to think bigger, you have to think in terms of a product, okay, in terms of all of these uh, ideas which will be expected if you join an IoT company, for example. Okay. So next we will talk about analytics in the Internet of Things. Again, here I'm not going to talk about cloud-based analytics as I mentioned in the beginning, but I will just talk a little bit about machine learning on IoT devices. I thought this is important and relevant because these days everybody talks about machine learning, artificial intelligence, right? At IIT Goa, when we receive applications for PhD studies, 99% of the applicants want to do research in artificial intelligence and machine learning. Nobody wants to work in my area. Okay. So, but the problem is they need to have some background, some basic knowledge of what is machine learning. Okay. And because of that, I thought that maybe we can spend some time on analytics part, but analytics on the device, not in the cloud. Okay. You have a session, I think, on the third day, which will go into the details of this. But my objective is more from a, again, as I said, from a design point of view. What kind of design choices you have. Okay. So this is if you look at machine learning or deep learning, they are all based on the concept of something called perceptron. Okay, which is nothing but a mathematical function. Let's just say this function where y is your output. This linear combination of inputs is essentially inner product of two matrices, x being input, w being weights, and b is some bias for some purpose. Okay, this is all that is there in machine learning. This equation, this relation. Okay. Now, if you all of you have studied, I believe, matrices, or you have taught matrices to the first year students, right? So normally, what is the size of a matrix that you teach? Say you are teaching matrix addition. What is the size of the matrix? Or say matrix multiplication. What is the size of the matrix? Say 3 into 3, 10 into 10, 5 into 5. Not more than that, because manually we can't work with bigger matrices. Here, the size of these matrices could be, you know, 500 by 500, 1000 by 1000, something like that, or even bigger. Okay. So the same addition operation, the same multiplication operation now becomes more intensive, because you have to do so many additions, so many multiplications, that takes a lot of time to get the result. So your computational requirements are huge. Okay, for this kind of application. Okay. So, and remember, in the beginning I said that your microcontroller or microprocessor is not as rich in computational capabilities as a microprocessor on your laptop or desktop, right? For the IoT case, which means if you have to do these kind of large number of mathematical operations, you have to find some other way of doing these operations on your IoT device. Okay, otherwise, if you do it just like that, then all these operations consume energy, right? So your battery will also drain. So you have to be creative here in how you do these things on an IoT device. Okay. In the last so this relation that I showed to you here is not new. This is more than 60 years old, and artificial intelligence, for that matter, is not a new thing. It was, the study started sometime in early 1950s. Then it was there for about 10-20 years. Then there was not much interest among the people, and historians call that as AI winter. In winter, people sleep, animals hibernate. There's less of physical activity. So in the same sense, the historians of science consider, after the initial 10-20 years, that AI fell into a winter. Nothing much happened. Then in the last 20 years, something's happened, because of which AI again became popular. One is, we now have massive compute hardware. So GPUs, multi-core processors, they came into the market. Okay. If you go back to 1950s, 1960s, the first microprocessor came out in 1971. That was 4004. A very small microprocessor, did only basic calculations. Okay. Today we have a lot of compute hardware at our disposal. This has happened in the last 20-25 years. So now you can do a lot of computation, no problem. You couldn't do that earlier. Okay. Then the availability of massive data sets. Okay. All of us have smartphones. We capture photographs on a daily basis. How many images do you think your phones have? Anybody here who has 10,000 images on his phone, his or her phone? Anybody here who has, say, 10,000 images on his or her phone? No? 5,000? 5,000? Okay, great. So, so now you can store 5,000 images on your phone. Okay. And if you go to cloud based storage or server based storage, you can have millions and billions. Okay. The amount of storage that Google or Facebook uses, the amount of data that Facebook users create on a daily basis is huge. And all of that, those images, those text are getting stored somewhere. So what has happened is that in the last 20-30 years, storage has become cheaper. Okay. It does not cost much to store something. You can buy a 32 GB memory stick, or memory card for maybe 300 rupees or 400 rupees, something like that. Okay, if you go back to say around 1995, 96, when there was no memory cards, you had floppy disk. How many of you have used floppy disk? Okay, floppy disk would have cost that much in those days. Okay, and then their storage capacity would be very little compared to your memory cards. So storage has become cheaper. As a result, a lot of data is getting generated, and then people have created these software frameworks like TensorFlow, Keras, which allow you to make use of these massive data sets to create some models, some neural network models to, for whatever task you want to do. So these have become the tools of the trade today. Okay. And these are facilitated because of massive development in semiconductor technology, massive development in cheaper storage, and very easy development of software frameworks like TensorFlow, Keras, etc. And all of these frameworks are intended for two types of devices. One is a laptop desktop, and the other one is IoT devices. So if you look at TensorFlow, TensorFlow has something called TensorFlow Lite or TensorFlow Mobile. That branch is mainly for creating models which would run on an Android phone or an iOS phone, or would run on some sort of IoT device like Raspberry Pi. Okay. So now we have these kind of software frameworks to implement some of these models on IoT devices. Okay. So this comes back to the same point that I made earlier, that this is our mathematical expression, and here we are doing some dot product of two matrices. The tools would simplify all this for you. Even the usage of activation functions, we don't have to get into the details of this. This is just for me to give you an idea that a lot of these things are pre-built in these development frameworks. Okay, you can use them, but the important thing for you as a teacher or as a student is to understand, at least have a basic understanding of how these things work. Because if the tool does not give you the result that you expect, then you have to debug it, right? You can't debug the tool because the tool is designed by someone else. Okay, so you have to go and debug your own code which is making use of the tool. Okay, so this is another example of a deep neural network. This was the paper of 1998 that actually triggered a lot of interest in artificial intelligence. This is one of those visionary papers. This was just about detecting digits, handwritten digits and characters. If you look at this architecture here, without getting into the details, the thing that you have to understand is that it requires a lot of storage for the weight values, the weight matrices, and then a lot of addition, multiplication, only this much. Okay, but then the scale is very high. Because the scale is very high, you can do it on a GPU And when people talk about AI ML, they talk about GPUs first. But if you want to do it on an IoT device, you have to make that scale smaller. Okay. So this is an example of models and how many weights they make use of. So these are some models. These are some of the most popular models. You can see that the number of weights is 431,000 or 61 million, 138 million. If you look at chat GPT and all, it goes into billions. Okay. Now from your basic computer science or electronics course, we need at least 8 bits to denote a number, right? I mean, you can of course denote 0 with just 1 bit 0 and 1 with 1 bit 1. Uh, in programming languages, say C or C++ or Python, the smallest data type is of 8 bits. Okay. So if you multiply this, say 431 into 8, that is the amount of storage you need to make use of this model. You multiply 61 million by 8, that's almost half a billion. Okay, that many bits need to be stored for you to use AlexNet. Where will this storage happen? So this storage cannot happen on chip. Okay, you compare that with your all of you have laptop or desktop. What is the size uh, of your RAM? 16 GB, right? 16 GB or 8 GB. Okay, earlier 4 GB. This is, you take 61 million multiplied by 8, that's half a billion bits. You see how many megabytes that is. Okay, so this can run on your laptop or desktop, okay, or GPU based computation. But in an IoT device, we looked earlier at Amazon Echo Dot. How much memory we have? 256 kilobytes, right? You can't fit these many weights in 256 kilobytes of memory. So you can't run these models on your IoT devices just like that. Okay, you have to do something creative to make use of these models or design newer models. Okay, so this is a graph that shows you hardware versus parameter size. So this is hardware here being GPU and parameters being weights in terms of megabytes. So you can see 600 megabytes, 500 megabytes are needed for these models, a lot of storage. Okay, and weights and other parameters, they need a number representation in whichever programming language you choose. C, C++, Python, Java, whatever you choose. Okay, so in C we have, generally we have single precision 32 bits, double precision 64 bits, integer 8 bits. So depending on what is your choice here, you will need that much memory. Okay, but choice also affects accuracy and all of those parameters. So you have to make use of these basic pieces of information that you learned in your first year or second year of engineering, or you teach in first second year, to make a choice. Okay, this also affects how you choose your microprocessor or microcontroller. For example, if your numbers are represented using a single precision, floating point, or double precision, you would need a floating point multiplier or a floating point adder in your microprocessor or microcontroller to make use of these numbers. Now, if you look at most microcontrollers, they don't have a floating point unit. Okay, which means you can't make use of floating point representation. You have to go back to use integer representations. Okay, on your laptop, desktop, GPU, no problem, but on IoT, this makes a lot of a difference. Okay, this also affects the memory read write bandwidth and how much time is spent in getting data from memory, and this also affects power, which is tied to your batteries. Okay, This is just some graph to show you how much it costs for data movement. So if you are familiar with microprocessors, there is an arithmetic and logic unit, that is your reference here, 1x. Compared to that, if you are reading from a register file, that's also almost 1x. RF to register file to ALU is just almost the same. But if you are getting it from a processing element, it's 2x. From a buffer, it's 6x. From off chip memory, a DDR memory, it's almost 200x. Okay. So this is all real power consumption, which will affect how your IoT device will function. Okay. Then division. So this is a sigmoid function. Let's just think of this as an activation function that makes use of a division operation. Division is considered an expensive operation. Okay, if you read any microprocessor microcontroller architecture, addition subtractions take less number of clock cycles, multiplication division take more clock cycles, and they also consume more power. Okay, which is also what happens with us. If we do mental math, it's easy to do addition subtraction versus multiplication and division, right? We have to exercise our brains more to do mentally some mathematical some multiplication or division. So you have to avoid this as far as possible, so people work with approximations. So in terms of summary of computational requirements, high memory amount of memory is needed, high bandwidth memory is needed. So these are some things which CPUs, GPUs can do, but your IoT device will not be able to do easily. Okay. So let's come back to IoT devices once again. So these are processors with less compute power, less on-chip memory, and battery operated, less operating frequency also. Your laptop runs at say 2 gigahertz or 2.3 gigahertz. Your IoT device will run in some kilohertz or say 5-10 megahertz range. Okay. So we call these kind of devices, we also call them as resource constrained devices compared to a CPU or a GPU. Okay. So if we go back, we take all of this and we want to do say machine learning on these devices. So two things we have to do: training, inference. So generally training we will do on GPUs, no problem. Inference we have to do on these devices. So this is an example. Your Amazon Echo Dot is actually making use of machine learning. Okay. The command that you give to Amazon Echo Dot, it does not get processed on the device. Okay, some of it gets processed, but the inference part, what are you saying? Are you asking it to play a song? Are you asking it to play a song of a particular singer? That happens at the back end in the cloud. Okay, only some initial cleaning of what you have spoken, interpretation of what you have spoken happens on the device. The rest happens in the cloud. Okay, or connected to Amazon server. Cloud meaning connected to Amazon servers. Okay, and then this here is a USB stick. It is from Intel. This does not need any network connectivity. You can plug it into your laptop and you can run machine learning models on it. Simple models for object detection, classification, digit recognition, etc. So this is considered as a test bed for developing IoT devices which can run some machine learning models. Okay. So the best thing is to make the model smaller. That's the best thing in order to make them run on these. So there are different ways of doing that. You can prune the model, quantize it, improve number representation. Pruning is simply removing more uh, neurons and weights. It is like you have a brain. So this is the brain, and these are neurons. You remove some neurons from the brain. That's it. You make the brain simpler. Okay. This is quantization. Quantization, I believe all of you know, you have already studied or you teach. So quantization helps in removing the variation in the numbers, right? Instead of having 100 different numbers, if you quantize those numbers, you will end up with say 8 different numbers. So as a result, it simplifies the storage, because now you don't need 100 storage, you can store only 8 numbers. Okay. It also simplifies computation. So these are some results which you can read on TensorFlow. This is on the light branch. This is meant for IoT devices and mobile phones. So by doing quantization, you are able to reduce the size by up to 75% of the model. Okay, and here are the platforms on which these have been tested. Okay, this is some effect on accuracy and latency, not so important. See, latency decreases by almost half. This is original and this is after quantization. And then this is the third method where we choose some other number format. This was developed by Google, bfloat 16, where instead of using the IEEE floating point format for real numbers, this is used. Okay, so essentially what are we saying? Essentially we are saying that we should build smaller models, that's all. Okay, and there are examples of some such models like MobileNet, SqueezeNet, YOLO, that you can try on your IoT devices. Okay. Okay, this is some power and latency related information. I think I will skip this part. Let's come to this part. So these are your tools of the trade, the software frameworks, the programming languages, if you want to do some machine learning on IoT devices. Okay, so these are various tools. Most of them are open source. Whatever is listed here, most of them are open source. You can download and try and learn yourself. Okay, I will quickly go through the microprocessor microcontroller part uh, from a power point of view. So we have seen earlier that your IoT devices consume power and we want to limit power consumption. So normally your microprocessor or MCU will run in active mode, but then there are various power modes, low power modes like sleep mode. The details we don't have to worry about. These slides I will share with your with Professor Golagi, and then you can take a look at these. There is sleep mode, there is wait mode, and there is retention mode. These are different modes in which the microprocessor or microcontroller can operate so that less power is consumed. Okay, huh. This is the fun part. This is more interesting. So battery powered. So battery powered means, what does it mean? It means that your application code will also need to be optimized for energy and power, which is if you're writing software, you have to think about energy and power consumption. Normally when we write software, we don't think about these things, right? Because we are running the software on our laptop desktop. But as I showed you earlier, if your software makes use of floating point numbers versus your software making use of integers, the second one will consume less power. So when you are building software to run on the IoT device, you have to think about the power consumption of the software. Then you also have to look at the microprocessor or MCU having an energy efficient architecture, which is what I showed here, different types of modes of MCUs. And then you should select the battery properly by looking into expected lifetime of the application. So there was one project in Saudi Arabia where they distribute water to the people in a city, and they wanted to capture information about water usage and leakage as well. Okay, so that the water distribution can be more efficient, and you also can charge the people based on how much water they consume and how much water they waste. Okay, so it's a network running into several hundred kilometers of piping. So they have to put sensors on those pipes. The sensors would capture information about vibration in the pipe. Okay, so whenever water flows through a pipe, the pipe will have some vibration. The sensor is capturing those vibrations as a proxy measurement for water flow. Now, if you are a public utility company which is rolling out this service, then the sensors that you have deployed, you would want those sensors to run for at least 2-3 years, right? So when you choose the battery, you have to look at the expected lifetime of those sensors. Now 2 to 3 years would be in the environment of that area. So Saudi Arabia is very hot. If you do that, say in Jammu and Kashmir in the winter, it's very cold. Now the temperatures have an impact on the batteries, okay, which is what you would have studied, or some of you may be teaching uh, in chemistry, in first year engineering chemistry. So what we need, and of course the batteries will also occupy space, right? When we talk of IoT, we think of small form factor devices, smaller devices, not a lot of space to put too many things. So these batteries have to be light and compact. They must have high energy density and voltage so that they can give you higher voltage and for a longer period of time. So generally lithium batteries or primary alkaline batteries are typical choices. Most of the laptops these days have lithium ion batteries, right? Because they can give you high voltage. They can also give you high energy density compared to zinc oxide batteries. So in the market, when you buy a AA or AAA battery, these are generally zinc oxide batteries, not lithium batteries. Okay, lithium batteries electrolyte contains no water. If you use a battery that contains water, what is the problem? Your IoT device will not function at a place which experiences severe winter because the water will freeze. If the water freezes, your battery is dead. Okay, so better is to have an electrolyte that does not freeze at that low temperature, or no electrolyte. That's the best solution. Okay. Also, if your IoT device is going to work in an environment which experiences very high temperature, means heat, then also you need specialized electrodes. Okay. So in industrial IoT, which is also an application of IoT, you can deploy IoT devices in blast furnace or in steel manufacturing plants. Okay, in the furnace side, the temperatures are very high. These normal batteries will not work there, right? So you need batteries which can sustain such high temperatures. It is not always the case that the battery becomes completely inoperative. It is just that it becomes uh, unresponsive. Okay, so let's take a look at this. So the environment in which your IoT device will operate. Okay, why is this important? So this is your AA batteries that you buy in the market. Here is the voltage on the y axis and time on the x axis, and then the operating temperature, basically the ambient temperature. So if your initial voltage is 1.5 volt, which is normally the voltage of a AA battery, at 20 degrees Celsius it will drop to 0.8 volt in an hour. Okay, so if you have a device, a microprocessor in an IoT system that needs, say, the typical operating voltages are 1.5 to 1.2 or maybe up to 1.1. This is the range of voltage that the microprocessor needs. So after roughly after an hour, your IoT device will become unresponsive. Okay, because the battery is not providing the necessary power supply. At 0 degrees Celsius, that happens in 4 hours, and at 20 degrees Celsius, this happens in about 8 hours. Okay, so the temperature has an effect on the voltage that your battery supplies. This is generally not taught in electronics courses. Okay, but this is very important. People think this is related to chemistry, but actually, this is all related to electronics. Chemistry is only to explain why this happens. Okay, but the impact is on electronic and computing devices. This is another one, which is storage temperature's effect on capacity. So imagine you are a company which is deploying 1000 IoT devices like I mentioned earlier, and you will store these batteries as replacement. Okay, so wherever you store, the ambient temperature of that storage uh, environment will also have an effect on the battery's capacity. So if say for example, if you take a look at this, if it is 40 degrees Celsius, from 100% it will drop to about 75% in about 6 years time. Okay, which means you may have bought the batteries today because you think it is cheaper, and then you store it for 6 years, and then after 6 years you find that your battery is not giving you 100% of what it promised to give you. Okay, it is not the battery's fault, it is a problem with your storage temperature. Okay, this is like food. you know you need to store some food in the refrigerator, isn't it? Because otherwise, like fruits for example, they perish very easily if you keep them at room temperature, most of the fruits. Okay, so this is just like that. Then then you have to look at the energy budget of your system. So a typical design, an IoT design, when you are doing this, is a typical budget. Okay, like 20% of battery capacity is for transmit activities to transmit data, 30% for receiving commands from some cloud based controller or some other controller, 20% for data collection and maintenance, 30% for support systems, idle sleep modes, blah blah. So this budgeting is very important. You will not be able to do this budgeting right after this talk. You will need to work on some of the things that I mentioned earlier in order to understand how to come up with this budget, so that you can have an extended life of for your IoT device. Okay, so this was that project which I have already discussed. Okay, now this was about batteries and their relation with energy efficiency. Next, I'll just talk about a little bit about computation. This is nothing research oriented, some very basic information, some which I have already discussed. So computation can be expensive. They make use of processor cycles to finish. They can consume more energy, drain the battery quickly as a result. Expensive computations like multiplication, division, sine, cos, etc. Okay. So what do? You simplify the computation. You can write A equals B times 4. So B is being multiplied by 4. But this is equivalent to B being left shifted by 2 bits. You try this exercise. Okay. So instead of doing an actual multiplication, you are only doing a left shift. Instead of dividing by 4, you are doing a right shift by 2 bits. Okay. This left shifting and right shifting are much less computationally intensive than actual multiplication or division. Okay, and the shifting of the bits consumes much less energy than actual multiplication or division. Okay, so with this you can evaluate an expression like A equals B times 10. This is equivalent to B left shifted by 3, that is B times 8, plus B left shifted by 1, that is B times 2. Okay, generally you don't do this yourself, the compiler will do it for you. So when you write software, whether you are compiling in GCC or in Visual Studio or something else, you have to look at the compiler optimizations that are supported. Most compilers will support this kind of optimization. However, if you are designing digital hardware yourself, then this you have to design yourself, this circuit. Okay, then we have concepts like clock gating to reduce power consumption, sorry, power gating to reduce power consumption. All of these concepts are there, which we don't have to get into. Then the read write that happens, that also consumes a lot of power. So you can reduce the amount of read write that happens on external memory. Okay, I showed you initially a graph which showed the cost of moving data around, right? So if you reduce the data movement, you will reduce the energy spent on data movement. Okay. Okay, so that was I think quite a lot of information from electronics, computation and system point of view. Any questions? Okay. Next, this will be very short, and I think after that we will have question and answer. Programming languages. So what is the most popular programming language today? Python, Java. Okay. What else? C sharp. And what is the most popular in IoT projects? Python. Okay. Embedded C. Okay. Why? Why Python is so popular? Comfortable, easy to work with. Data. Okay, it's an interpreted language, correct. So Python, yes, that's the most popular programming language for IoT projects. The reason being, first of all, it supports many different kinds of IoT devices like Raspberry Pi, BeagleBone series devices, etc. Okay, so the support is there. Then there is a rich collection of Python packages and software development kits for the IoT protocols. Okay, so you might have already learned about MQTT and COPE. These are two protocols related to IoT. So Python already has packages to support these protocols. So even if you don't understand the protocols completely, but you understand the formatting of the packets in the protocols, you can make use of these packages. Very easy to use. Okay, and then the easy APIs, application programming interfaces for controlling general purpose input output pins and for interfacing sensors. Okay, and it's easy to learn. Python is easy to learn. It's an interpreted language, not a compiled language, so you can see the result immediately whether you're doing right or wrong. Okay, all of those benefits are there. Okay, now Python is a good choice, is an excellent choice to get your application working on an IoT like device like Raspberry Pi, etc. Okay, but if you want to work with Arduino, for example, then Python may not be a good choice. The Arduino has its own programming languages, which is more like C. Okay, so you may need to know that. But think of an IoT project. Okay, so this is your IoT project. This is your device. There is some client or front end, and there is some back end. Okay, so you will need some language for the front end part, and you will need some language for the back end part. Back end being like a database, okay, or a dashboard. Dashboard would be more on the front end side. So on the front end, how do you create a dashboard? So a dashboard, a web based dashboard, CSS, HTML, JavaScript, right, React, those frameworks. Back end would be some database like MongoDB, SQLite, etc. Okay, and here on the device you will have your Python or C. Of course, some of the front end you can do in Python also, uh, but generally Python would go in the device part. Okay, and then these are the communication channels. Okay, so REST APIs or other APIs that are needed, they have to be supported. Okay, so programming the IoT device you can do in Python and C, but the front end and the back end, if you want to build a complete IoT project, will require some other programming languages also. Okay, which you will work with or your friends will work with. So what we can do is we can take a look at some projects. Is the internet connected here? No. No. Okay. Okay. So if you go to these links, so this is monitor home environment Arduino IoT cloud. This project makes use of an Arduino board to monitor the temperature, the humidity, the pressure in your room. Okay, so it's a sensor board which has a Wi-Fi shield. It connects to your home Wi-Fi, and then it connects to Arduino IoT cloud. So if you have an account on Arduino IoT cloud, you can register your device with uh, uh, on Arduino IoT cloud, and you will be able to see the information that your sensors have captured on a dashboard there. Okay. Okay. So for this project to run, you will need to understand about programming Arduino. You will need to make use of Arduino IoT cloud, but you will not do any programming on the cloud part. You will essentially do configuration and device management and data analysis. Okay. Okay. Can you open that link, please? You can click on that link. It will, yeah. So this is a project that makes use of Arduino IoT cloud. So this is that sensor board that connects to an Arduino computing platform, and then over Wi-Fi you have a web-based dashboard in the cloud, and you can see the information. Okay. So if you look at the technology stack, as we say, for this project makes use of uh, 3 4 different types of hardware. It makes use of Arduino and the related programming language. It makes use of a dashboard on the backend on IoT cloud side. Okay, so that's the complete tech stack for this simple project. Okay, it does not, of course, deal with authentication, device configuration management, all of that, which I showed you in the business case study. But this is good enough for you to understand how a tech stack looks like. Okay, can you open the second link, please? The second link in the PPT. You can copy. Yeah, you can copy paste. It's there. It's this one. So this is a farm security project with cellular IoT and AI. So in this particular case, uh, if you scroll down a little bit, yeah, just here. So it makes use of a Raspberry Pi Model 4. Then it makes use of an AI camera. There is a Blues note card, which is essentially a small PCB for a SIM card like device. Okay. It makes use of Twilio SMS messaging API. This is for giving SMS based alerts. And then this is the Blues Note Hub, essentially backend network service that connects to the cellular card here. Okay. So what this device basically does is it captures some images using this camera, and then the Raspberry Pi processes it to detect some trespassing or something like that, and then uh, sends that alert using the cellular network, the mobile phone network, to the dashboard side on the Note Hub. And then if a user has subscribed to this service, they will get an SMS alert using the Twilio messaging app. Okay. So this is the tech stack for this kind of simple project. Now here, if you are doing something like this you will all of this you will simply buy and make your project. Okay, you will only write the software that will run on Raspberry Pi 4. You will configure the cellular board. You will configure the Twilio SMS messaging app, and then the dashboard on the backend side. Okay, so this is an example where you take an IoT platform and you build an application on top of it. Okay, and this is quite good. It gives you an idea of end to end IoT build, of course, without getting into hardware build. Hardware build is different. Okay, you can build all of these things on your own as well, including hardware and software, but that will take a lot of time and you will need to learn a lot more things. But if you just want to try out IoT projects, these are good ways of trying them out. Okay. Okay. So that brings us to the end of the presentation, to my talk. I'll be happy to answer questions. I know it was long. I went through quite a number of things, uh, but I hope you captured at least 10% of it. So, any questions? So, how many of you have actually touched a Raspberry Pi board or an Arduino board? All of you. Very good. So, then you can do these kind of projects. You know, you don't have to build a Raspberry Pi or an Arduino board on your own, but you have to work on the application side. Okay. Okay. Any other questions? Okay. So here, if you see this business case diagram is for a utility company, for an energy utility company. Okay. On this side, we have the basic smart meters. Okay, the smart electrical meter. This smart electrical meter will be provided by the utility company. Okay. Now that utility company must have some way of configuring this smart meter. So imagine you are running a utility company and there are say 100,000 of these smart meters to be deployed. It is not possible for you to send 10,000 people to 10,000 houses to configure the device, right? So what will you do? You will, the consumers will collect or you will ship the device to them. You will tell them to connect to some socket, and then you will have, over the network you will have access to the device to configure it, for the purpose of, like, who is the user, what is the location, what is the user id, when is the billing cycle, when does it start, etc., etc. Okay. You will also configure some rules here. For example, there could be features in a smart meter which could be turned on or off by the user, and there would be some features which the user should not be able to touch. So user configurable features you have to enable for the user, and those that are not to be touched by the user you have to keep them for your own. So that kind of device management you will carry out over the network. Okay. Then this meter, depending on the type of features in the meter, this meter may be capturing information about energy you are consuming from the grid, or energy you are consuming from say your own solar panel. Okay. It may be capturing some information about when you are using solar panel energy, when you are using grid, when you are off grid. That information will go back to the backend side here. Okay. Where the utility company will be doing further processing of that information. Okay. It is also possible that you as a consumer, you may be supplying energy to the grid. Okay. So you have excess energy with you because of your solar installation. You want to sell that to the utility company. So that information will also come through this meter only back to the utility company. Okay. And all of this information will be used on the back side by the utility company for billing and all of those analytics. In addition to that, whether your meter is online or offline, that also the utility company has to know. Okay. Because if I have deployed say 10,000 meters, I must also have some mechanism in place for their maintenance and upkeep. So whether the meter is online, offline, or for how long it has been online, offline, that information has to be captured again somewhere. Okay. So that will also come through some wireless channel, also through wireless or through some wired mechanism, whatever is the network mechanism. It has to come back to the utility company where it will use that information to have a maintenance schedule in place. Okay. Then if a user wants to disconnect from the utility service and wants to switch to another utility service, those requests will also come through the user sitting in his house. Now when that comes through say some other application here, not the meter, through some other web based application, that information has to be used by the utility company to reconfigure or stop the meter based on the request. Okay. And then the retrieval will happen later, or they may not retrieve it depending on what is their business case for that. So these are some of the examples that are described here. The diagram is a little bit too complex, but that's the basic idea. Okay. Any other any other question? Yeah. So IoT devices related to in the medical sector, right? So one example I gave you initially was of a insulin pump that connects to an app on your phone. Okay. Other example is so when you go to an operation theater, let's say you go to an operation theater as a visitor, okay, then when the nurse comes in for an operation to happen, she carries a lot of instruments, right? A lot of instruments are wheeled into the OT, so they have to keep a track of the instruments which have come to the OT, and then instruments which are actually used during the operation, they have to keep track of that. And then once the operation is over, they have to match that the instruments which came into the OT, like scissors, knife, scalpel, etc., etc., and their number, and they have all come back. So this is done so far manually, most places, even in countries abroad, okay, in other countries. But now there are some companies which are automating this, where they have RFID enabled uh, instruments. So if you have a Caesar, the Caesar carries an RFID tag, a small RFID tag. That information is now captured on an electronic system. Okay. So once, as a result of which, now you have to do some replanning of the operation theater in terms of how the instruments will come in, from which direction, and from which direction they will go out, because accordingly their in or out status will be captured by the system. So this is another example of an IoT. These things do not connect to the internet, okay, but the devices are electronically tracked. The other advantage of this is sometimes some instruments get left in the, when the operation happens by mistake, some instrument is left in the operating cavity. Like you might have read about newspaper reports about seizures being left in the in the operating cavity and things like that. So RFID based seizures will keep transmitting. Okay. So if I run an RFID scanner after the operation is over, it will tell me that nothing has been left in the operating cavity. Okay. Uh, and it will help me keep track of my instruments. So this is a concept that some hospitals in some countries have adopted, and they are piloting it in their operation theaters. Okay. This is an example of a medical IoT device. Okay. The other examples, like not absolutely medical, in sports we measure our temperature using a thermometer, right? For performance sports, the critical or the core body temperature measurement is very important. So how that is done is that the athlete will swallow a pill which actually contains a temperature sensor. Okay, so if I swallow that pill, as it passes through my digestive tract, it will keep on transmitting the temperature of my digestive tract, and it will be captured in an app. Okay, and finally it will be passed out. So by keeping track of that temperature, my coach will know whether I am in the right condition or not to say run a 400-meter race. Okay, so this is another example of an IoT device, but this is not connected to the internet. Okay, but except for that thing, everything else is there. Okay. You are referring to machine learning models deployed on IoT devices and something going wrong. Who is responsible in that case, right? Well, in some countries, there is this is an ongoing debate of who will be responsible if something like this happens. Whether the person who wrote the model, which you treat as black box and use in your design, okay, or you who built the design and actually sold it to the user, Uh, there are no clear guidelines on this anywhere in the world. Okay, this is a matter of debate as of now about who will be responsible. But but there is an argument that the person or the company which sold the IoT device, and because if I am a consumer, I am buying it from you, say you are the company. If something goes wrong, I am suffering, I will point the blame to you. You will be responsible. You may blame the person who created the model. That may happen. Okay, but for me, you are the person or the company who is responsible for this. How courts will treat this will depend on how the facts are presented. Okay. Any other question? So if any other question? Okay, so if no other question, then we will stop here. And I will thank you all for listening to me for the last 2 hours. Okay.
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insights you have provided.
I would like to request Bahubali Akivati sir to present the memento to our today's resource person, Dr. Sharat Sinha. I request everyone to follow for 5 minutes break and we shall gather back at 4:40. 35.
ಹಲೋ ಹಲೋ.
ನಂಗೆ ಅನಿಸ್ತೆ ಬಹುಶಃ ರಮೇಶ್ ಸರ್ ಬಂದಾರ ಅವ್ರು ರಾಹುಲ್ ಫೋನ್ ಹಚ್ಚಿದ್ದಾರೆ ಸೆಷನ್ದಾಗಿದ್ರೆ ಬೇಡ ಸೆಷನ್ ಹೊರಗಿದ್ರೆ ಬಾ
ಹೌದಾ.
ಏನು ಹಾಂ ಐತ್ರಿ ಐತಿ ಅವ್ರು ಬ್ಯಾಚ್ ಮಾಡಕ್ಕೆ ಬೇಕಂತ ತಗೊಳಲ್ಲ. ಆಗೈತೆ ರೀ ಇದು ನಾಳೆದಿದೆ. ಇದ್ದವ್ರ ಕಡಿಮೆ ಹೆಂಗೆ ಮಾಡ್ರಿ ಸರ ಅದನ್ನ ಬಿಟ್ಟು ಇವ್ನೇನು ಕುಂತಾರಿಂದ ಈ ಆರ್ಮಲ್ ಒಂದು ಹೇಳಿ ಒಂದು ಕಡೆ ಕುಂತ್ಬಿಡ್ರಿ ಆ ಟೈಪ್ ಮಾಡ್ಕೊಂತ ರಮೇಶ್ ಸರ್ ಖುಷಿ ಆಗ್ಬಿಡ್ರಿ.
ನಾನು ಬೋರ್ಡ್ ಚಲೋ ಮಾಡಿ ನಿಂತಿರ್ತೀನಿ ಅವಾಗ
ಅನೌನ್ಸ್ ಮಾಡ್ರಿ ಪಾರ್ಟಿಸಿಪೇಟ್ಸ್ ಬರಾಕ ಅನೌನ್ಸ್ ಮಾಡ್ರಿ.
ಅದು ರಿಮೋಟ್ ಇದು ನೋಡ್ಕೋಬೇಕು ಅದನ್ನ ಎರಡು ಅಪ್ಡೇಟ್ ಮಾಡ್ಬೇಕು.
ಅಲ್ಲ ಬೇಕೇ ಮತ್ತೆ ಅದು ತಗೋರಿ ಅದು ಹಾಕಿಬಿಡ್ರಿ ಅಭಿಷೇಕ್ ಅಲ್ಲ ಎರಡು ಅಪ್ಡೇಟ್ ಮಾಡ್ಬೇಕು.
Everyone, please gather quickly.
One more time.
The session 4th will be beginning soon. Please gather quickly.
ಹಲೋ ಹಲೋ ಅದಿಲೋ ಇಲ್ಲಿ ಬಟನ್ ನೀವು ನೋಡು ಕೆಳಗಾದ್ರೆ ಹಲೋ ಬಡಿ ಹತ್ರ ಹಲೋ 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 ಮೂರು ನಂಬರ್ ಹಲೋ ಎಲ್ಲಿತು ಚಾಲು ಇತ್ತು ಹಲೋ ಹಲೋ ಓಕೆ ಸರ್ ಬರ್ತಾರೆ ಫೋಟೋ ಒಂದು ಬರೋಕೆ ನೋಡು ನಮಗೆ ಡಾಕ್ಯುಮೆಂಟ್ ಇರಬೇಕಾ ಹಾಂ ಹಲೋ ಬಾಬುರಿ ಸರ್ ಸರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿಬಿಡಮ್ಮ ಟೈಮ್ ಆಕೈತಿ ಹಾಂ ಸ್ಟಾರ್ಟ್ ಮಾಡಿಬಿಡ್ಲಿ ಟೈಮ್ ಭಾಳ ಆಯ್ತು ಎಸ್ ಸರ್ ನಿಮ್ಮದೇನು ಅನೌನ್ಸ್ಮೆಂಟ್ ಇದೆ ಎಸ್ ಸರ್
Welcome back. The fourth session to be held is for article discussion by Dr. Ramesh Kagalkar from NCET Bangalore. I would request Shilpa to introduce our resource person to the gathering.
Good afternoon to everyone. I feel very proud to introduce our resource person, Dr. Ramesh M. Kagalkar. Sir has 21 plus years of teaching experience as well as 5 years of research experience. Currently, Sir is working as a professor in the Department of Information Science at Nagarjuna College of Engineering and Technology, Bangalore. Sir has completed PhD in Computer Science and Information Science at RRC-VTU Belagavi. Sir has guided 2 research scholars in CSE at KLECET Chikkodi Research Center. Sir has 13 plus research papers publication. Also more than 60 plus research papers published in international journals. His research profile is citation 334, H index 10 and I index 11. Sir is having collaboration of research works with a various international and national level researchers. And coming to his research proposal communicated with a research proposal submitted to VGST Bangalore and SERB International Research Experience DST in the academic year 2022-23. Sir has received 5 plus award in research work. Sir has also worked as a key resource person for the on the topic of artificial intelligence for dentistry for KLE Dental College, Belagavi. With this brief introduction, I present Dr. Ramesh M. Kagalkar. Thank you.
Start madam, sir.
Thank you, Shilpa. I would like to request Bahubali Akwate sir to welcome Dr. Ramesh Kagalkar.
Thank you, sir. Thank you. Thank you, sir.
Thank you, sir. I would like to hand over the session to Dr. Ramesh Kagalkar, sir.
Thank you, madam. Hello. Audible. Okay. Good evening, one and all. Myself, Dr. Ramesh Kagalkar, and today my session is article discussion. So, the word article itself is it's a research paper. Okay, so we need to discuss about research paper. As morning session you have attended, the FDP theme of the FDP is internet thing and emerging application. Okay, under this uh, today and tomorrow we are going to discuss about the how to read a paper and how to write. In between reading and writing, in between these two, so many things are there. We need to collect some takeaway from the paper. So how to read a paper is an art. Okay, so I am going to discuss a few more things during this session. I'm going to discuss the contents are startly I'll introduce how to proceed for the article discussion, then about technical article, outline of the standard research paper, how to read research paper, in-depth understanding of technical steps. We need to know many things are there. Article summary, content, format, discussion, and conclusion. So in this last point, I'm going to share the some. I'm asking you to make a batches of six member, and I'll ask you to come up with some points. So I'm going to discuss at the end. So tomorrow session, before going into the writing of particular paper, we need to understand some of the key points from the particular one case study papers. Okay, let us start with here. The aim of the today article discussion is we have considered as per the AICTE guidelines. Your coordinator has requested me to consider any one important paper which is related to the IoT. So I have taken Internet of Things application and opportunities and threats. The paper itself shows that it is a IoT based paper where we need to understand what are the opportunities, what are the threats. So in this paper, many things he has given. This is not a regular paper. It is a review paper. Review with some technological things they have addressed, they have studied, and they have come up with their own idea and they have wind up paper. So in this paper, what to understand is very important. How to read a paper is an art. Okay. So again, here at the end of this discussion in the paper, we need to summarize the content in the paper. What exactly it is there, and also we need to find out the some of the issues. What are the issues or the drawbacks of that paper? That ends the reading part. Then when you start writing a paper, no, in between we need to take away some points are there. So I am going to discuss. Then again, see what is technical paper. Technical paper itself is a research paper. Okay, so as I said, research paper, what is, how do you define what is research paper? It is like someone work, some other researchers work, they are written in the form of paper. It may be IEEE, it may be Springer or any other format. So they are showcasing their paper, their work in the form of 10 pages or 15 pages. So actually their research work is too much. So that is what the research paper. So I have written the some of the words also. It is a type of academic writing that provides an in-depth analysis and evaluation of a single topic based on the empirical evidence. So empirical word itself is an implemented one. So whatever their coding will be there or their experiment results, they come up with a result, they are producing evidences. Then moving to here, the outline of the standard research paper. So looking into the, before reading any paper, we should remember this. Like a title of the paper will be there. So title itself is very important because which domain we need to understand here. Abstract, introduction, literature survey will be there. Problem definition and objective will be there. Overview of the system, methodology, mathematical modeling. This is very important again. Then again, database creation, representation and consideration, technical implementation. In this hardware and the software, we need to understand. Then again, result analysis, table value, graphs, scope of the system, conclusion, future work references. These are the important standard we need to maintain. And how to read the research. Now the part is very important here, how to read. So exactly. So as a research scholar or the PG or the UG students, so their main focus is to read. How to read a paper. That's what I'm going to discuss today. As I said, it's an art of understanding the researcher work. Research any researchers, they are come up with a good papers in the good article. So we are downloading simply with the help of guide, the advice or our own PG. We are like PG students are want to do some research work. So they wanted to download some papers. How to read is a first question. So here, what the students or the scholars has to do first, they have to identify the particular topic, that is identifying the domain of interest, which domain they want, whether the guide domain or the individual the knowledge. And what they have to do is immediately they have to start scanning the abstract, introduction and conclusion. Okay, these three things are very important. So I'm going to discuss in the next level. There are three passes will be there. So here, any paper we need to understand here abstract, in introduction and conclusion. And also after this we need to grasp the main important thing is what are the objectives are there in this paper as well as findings. Okay, so these things I am going to discuss in detail later on. Then here, in this, along with this, if the paper is relevant to the particular our domain, we need to understand the heading, subheading, main headings, and also figure, and understand the complete structure of the paper of the one researchers. Okay, then what are the key takeaway from that paper? What to read? See, after downloading any one paper with your domain like image processing or video processing, after downloading, if you start reading, no, if you take 8 hours, 6 hours, or whatever maximum time you wanted to spend your time to read, no, it is very difficult process because someone has written. So you what important key points you have to extract. These are the some points will be there. So you need to identify the what exactly they wanted to do. That is a research question. What methodology they are going to use to solve that particular question. Major findings. Finding means what are the gaps are there. So I'm going to discuss again. Finding means what they have come into the conclusion for implementation of the particular things. Then their implication stands for here the potential outcome and the effects. So as they have undergone some research work, obviously there are some outcome will be there. Those outcome is very useful for the society, we need to understand. And so effect, so that effect will be considered for the other researcher work like a future scope. Then very important is we are going to extract here some essential understanding of the paper, what exactly the author contributed work in the particular field, or as well as the limitations. We need to identify these two, potential contribution as well as the any important drawbacks left behind in that particular paper also we need to understand. Then usually how we have to do the referring the paper means, firstly we come up with some idea. So I wanted to do a research, I wanted to study a particular one paper in the image processing or the whatever the area, video processing. So firstly I will go to search into the particular in the internet. I'm going to search technical literature searching just title or the domain. After that I'll discuss with some discussion with the friends as well as the seniors or guide or the co-workers, and technical discussion. After the technical discussion, individually we are thinking, oh, I have to go for in this way. So I start writing one or two line. After that I want to refer again internet. Through internet I am going to refer good journals like reviewing articles like a Springer elsewhere, same domain, some published latest paper I am going to download or reading. So that what part I am explaining here. So reading, how to read. Okay, so again see here, these are the some important steps are there. How scientists can search research papers when they first see them. So I don't know, very firstly I wanted to see the particular paper, what to read. So firstly abstract will be there, you need to go through only abstract, because entire paper it is very difficult because he has spent 1 or 2 or 3 years time to come up with the results. So firstly quickly overview the abstract, then again introduction, then again you need to understand methods, what result they have obtained, then discussion. So at the end, results with a database creation, how much data they have used, what quality they have used, then reference. Okay, here there is a some flow will be there. In this flow the main focus is a red dot, then again detailed reading, then focus scanning, quick scanning. These are the some in between points will be there. So this flow, firstly title should be very, means in the title itself is a domain, you should have a good knowledge of domain. If you don't have a domain knowledge, then you start reading many things and it is no use. Okay, that's why it is a main focus is first you have to decide which domain. Later on, second one is detailed reading. Detailed reading is methods. What methods in the title itself will come to know, okay, what what they have wanted to do. Then in the methods images, you will go through images, we will come to know, okay, this is input, this is output, how they are processing, what technique they are using, with help of only pictorial representation. After that, results or result in the graph or the table values, samples, this that, you will come to know, okay, they have taken this input, output, desired output, results, this that. Then again, discussion also, images, some certain images will be there, screenshot, these that. Then also you will come to know. So that is what detailed reading. Focus reading means not that much in detail study. Okay, that is there in between, like introduction you have to go through, small little time you have to spend. Then similarly, references also, which are the reference they have used, whether they are used quality papers, good image, that like 2023-24 papers with the standard journals. Okay, that we need to understand. Then look at here, to read any paper, there are three methods are there, three passes we call it as. First one is a general idea. The pass itself is one. First one is general idea. So generally we have to see in the paper. Okay, so general idea. Second pass is like a basic content, but not in detail. So basic things what they have covered, that also we have to see. Then third thing is the pass three, in-depth understanding. So in-depth understanding, what we need to understand. So the general idea is hardly 5 to 10 minutes. So just quick view whether it is mine paper or some other domain. Then again, basic content, again you need to understand the what are the important concepts will be there. So that what I have drawn here. The first one is it gives a general idea about the paper, that is called first pass. Second pass let you the grasp the paper content, only content of the paper. Third pass is in detail study. Okay, so let us start with the first in general idea. So in general idea, what we wanted to understand here is, it is like a bird eye. Okay, just go through quick, like a 5 to 10 minute, any paper you just download. I see I am good in video processing, so I am very much interested to read, to continue my research work in video processing. Then what I have to do, we have to download on paper, we have to see the title, download it. After downloading, the first pass one is, I'll give us a homework also. Okay, so in the past one, general idea, it is a bird. Okay, bird eye view. So hardly 5 to 10 minutes you have to spend the time to know what exactly, whether the paper is relevant to my domain or not. Sometime what happens, we are good in the particular one domain and the paper is different. So after 1 hour, 2 hour, after reading everything, then I come to know that from the guide, hey, it is not related to your paper. Then again, unnecessary time waste. No? So that is what the general idea will tell you to exactly whether it is related or not. So again, here what you have to do is, we have to read only three things. One is the title, abstract, introduction. So with these three, we come to know that it is our relevant. So like section, subsection, heading, if interested, you can go in detail, and conclusion also. These are the points as well as the reference which are related to one. So with this, within a 5 to 10 minutes, we come to know that it is our related. That is what the general idea. So then in general idea, I come to know that this is relevant to my domain. Then go to the past two. In the past two, basic content but not in detail, because again, after the first pass, I'll come to know this is related. But after in detail studying, I come to know that, oh, it is again image processing. So many areas, image compression will be there, image processing will be there, image segmentation will be there. Many different domains are there. So in that particular domain, whether it is my paper is there or not. Okay, so that is here, read carefully but ignore details like a proof, and for examples, proofs are there, mathematical. So then you will come to know, so it is not my related. Then you need to spend a 1 hour time, second pass, whereas the first pass hardly 5 to 10 minutes. Here 1 hour you have to spend a time, and also you go through some figures, diagram, illustration, graphs. Okay, some bar chart error will be there, you just go through. Okay, you will come to know. And then again, next one is mark relevant unread references. In the paper, you come to know that some citation is not proper also. You will come to know. So this citation, okay, this paper is related to this domain. There may be a same domain, but different domain paper they have cited. So how collaboration they have done, that also you can understand in the basic content. Okay. Then again, in this pass two, we need to understand these 5 C's, very important. So what you have to understand is category. First one is category, second one is context, Third, correctness, contribution, clarity. So category is nothing but what type of paper. Okay, when you start reading no in the past two, you will come to know whether it is a regular paper or the survey papers or some implemented paper or in between category. Which category? Okay, it is regular paper or review paper. Next one is context. Which context it will be there? Whether the same domain with image processing or image enhancement or video processing context is there or not. Okay, so you are going to check. Then again, correctness of the all the alignment, result is proper or manipulated, or they have not done, they have not contributed anything but fabricated some work, or statements are not correct one. So these that, see, researchers, many researchers are there, they are simply downloading, they are making the paper and they are publishing. So we need to understand, because we wanted to proceed for knowing the detailed paper, we have to see the correctness. Then again, contribution. So in the contribution in the paper, what they have contributed, author, you maybe heard about previously, like when you submit the paper to the journal, no, so journal reviewer send a message, what is your contribution in this paper. Okay, that is contribution. In paper reading, you need to understand what is the author contribution, whether it's simply downloaded or simply these that added, simply writing a statement that is also there. Then third one is clarity, whether the image quality, result is he implemented, any evidence they have given, that is clarity. English statements also, some erroneous statements are there, some mistakes. Okay, that you have to find out here. See, without this, if you try to read, no, at the end will come to know this is your guide or your what say supervisor say, no, no, this is not good paper. After 1 week you have spent a time to read this, then again no use, no. So that's why you have to concentrate here. Then again, third pass. In the third pass is very important, it is in detail, in-depth understanding. So here you have to spend minimum 10 hours, minimum I'm telling, depending upon the individual candidate, you can spend more than 10 hours also. Here what you have to understand is effective understanding of the research paper. We need to follow this in detail. One is identifying the domain of the paper. Next one is reading abstract, introduction, literature survey, gap analysis, problem statement, objectives, overview of the system, and the methodology, mathematical modeling, implementation or the evaluation of the system, result discussion, scope of the system, further scope, then again conclusion, references. Let us see one by one. Identifying the domain of the paper. As I said, no, so which domain you are interested. So it may be image, video, IoT, AML, cloud computing, networking, distributing, cybersecurity, whatever. Irrespective of domain, you should firstly domain you have to define. After that, next one is the read abstract. Okay, so title is over. After that, next come into the abstract. So the read abstract, very important here is what do you mean by abstract? Abstract is nothing but it's a concise the description of the particular researcher work. Means they have written short story. Like before releasing the movie, there is a trial. No? Trial will come to know that whether the movie is good or bad. Okay, so like that, the abstract is very, in the abstract, everything they have written in the smart way, because the scholar has to need not to spend a complete time to read complete papers. Okay, so that is what here, and it also the abstract will sell the particular researcher work, researcher the main focus. That is, it is supposed to sell the researcher work. That is also very important here, and also it convince the reader or the reviewer that it is interested for the image compression or video processing or IoT. Okay, so in the abstract, what you have to understand here is these are the some points I have written here. The here background will be there. Okay, background or the introduction you need to understand here, two line. Then again, what methods they have used, two line they have written, you need to extract. Then result and finding, they may written like 98% or 88% is achieved. Then again, conclusion, they have exhausted the work. So because of the time constraint, they have written these that we have achieved. That also we need to understand. So like abstract is including this introduction, method, results, discussion, and the conclusion. So these points we need to understand from their particular paper. Then again, moving into the what to read from the particular paper. Okay, here. So from the abstract, we need to identify, we need to study in detail like aim. The main aim of the paper we need to understand here, what exactly researcher wanted to do. Okay, so in that paper, we need to understand here what exactly research want to do. Then again, overview of the innovative idea. So what the researcher idea will be there in mind. So we need to understand. Then to solve this aim, what methodology they have solved, what methodology they use, whether they use some techniques, SVM or ANN model they used. Then database, if it is the project, if it is research work is related to the database, how they have created database and how they have represented and how they have considered for their work. And then result achieved. So what result they have achieved? They may return like 98, 88 or whatever the percentage they have written. We need to understand. We have to note down. Then conclusion drawn. We come to know that okay, the researchers is contributed so and so. Hence, we can take away this also conclusion point. Then moving into here, as I said, here is the important things abstract look like. In the abstract, there is a context will be there. Context. Then that means aim. Context and the purpose will tell us the what exactly aim. Then methods are there. Which method they have written here. Any paper you just go through. Then here is the finding. So finding is nothing but results. Significance. What are the main importance? Significance. We need to identify here. Then again look at here introduction part, what you have to read, what you have to remember. In the introduction is we need to identify the domain of area, which domain is the paper written, and also real-time social problem, how they have specific domain they have considered, as well as they are going to consider the real-time problem. Also we need to understand from the particular introduction section. Then in literature survey, look at here in literature survey, what is literature survey? You are referring the one paper. In that paper, whether he is referred some other paper, that is what literature paper. In the literature paper, how the researcher of the particular paper, it may be one or two researchers, how they have taken the from the individual paper. These are the points: aim, methodology, database consideration, result and conclusion. This point how they have taken from the one paper. Also how many paper he has considered and on what type of paper he has considered. Okay, I have written research papers were referred and how the many papers were referred. Okay, means what are the standard papers he has considered and how many papers we need to understand. Because we are referring one paper means we need to understand he is referred only Taylor Francis reference, Springer reference, ACM papers, okay, the elsewhere papers. Okay, how many papers he has referred also, that is also important. Then gap analysis, it is a very important. What do you mean by gap analysis? Means analyzing the gap between the different researchers. Look at here in the graph, there is a gap analysis, like this is a one point, current point and the expected point. So in between one researcher, they wind up their work in this point, one more has winded up here. So what is the gap between this? Presently AIML and the IoT are emerging. Okay, so we are working only a particular level. So this is what here current state. The current, we are in current state, many things, many research is going on, many products are coming, we are enjoying. But what about the futures, desired state? We want, no, we want extra, means advanced device also we are looking. So in between what is gap? So still researchers are working only here. What about this? We need to understand. So in the paper, in the author, he has referred 6 paper. In this 6 paper, one more paper difference. Like that we need to understand. That is what gap analysis. So it is a very simple way is a statistic technique used to determine the gap between the current state and the desired state. What I told here. And here after knowing this gap, we need to have a one plan. We need to design. Because we are reading, no. So we come to know that this is a gap. We have to come up with a one plan to overcome this gap. So here the purpose to examine the, see the main purpose of gap analysis is to examine the two states and ascertain the causes for the gap. As I said, no, in between gap there are some causes will be there. We need to consider in the plan, we have to write. Ascertain the cause for the gap and recognize the effect plan for the action to meet the objective of the desired state. So in the desired state, we wanted to achieve a desired state, we need to focus in this way. Okay, presently best example I can tell you, Alexa will be there, right? Alexa, we are using Alexa for many purpose. We need not to search in the Google. We don't have a time. We are very busy in this, that working. So suddenly I want to ask some this, that information real time. Then I can ask the Alexa. So Alexa, what is time now? Alexa, what is the political news? Automatically it will tell. So in that case, gap is, it is still it is not updated, because the in the server whatever updated it will give. If it is not updated, it will not give answer. Okay, for example, who is the chief minister? Automatically it will tell. Suppose government has dissolved evening 5 o'clock and 6 o'clock you are asking again Alexa, Alexa, who is the chief minister? Then again it is confused. After one day, the server will get updated. Till to that, in time you are try to ask, no, it will say the present chief minister name only. It is changed also. That is what the problem. So like that gap. Okay, so the gap we need to understand. We have to come up. So we are looking for what? See, as soon as the government dissolved, immediately next moment, immediately result has to come, because in the YouTube also, as well as the television also, immediately result will announce, and who is the next chief minister immediately announce. No, same way here we are expecting in the Alexa or the Siri. Okay, so like that here. So this is what gap analysis. This plan you have to understand. Then moving into here, as I said, no, so same thing here, points, these two gap we need to understand. So one more way I have written here, it is the assess the difference between the actual and the expected performance in the researcher work. So two different, how many papers they have referred, one paper, 5 or 6. So what the performance will be there, gap. Then it also analyze the performance between each research work carried out by the different researchers. That's what I told, no. So different researcher work we are going to understand, and we need to, so to improve further. So let us see here one more diagram very clearly here. Research gap is nothing but, here is the one activity, one more activity will be there. So this is the future activity. So in this activity, less or no information available as presently, whereas outdated research is going on. So we need to understand this. This is called research gap. So we are moving to here, provide a direction to the future research. So in we are reading one paper means we need to understand some issues. Okay, that is what the main important here. Then again, problem statement. Next, problem statement. After knowing the gap analysis, I come to know that okay, this is are the some issues. I wanted to define my own problem statement better than the previous one. No, so what the previous researcher they have done, no, you have to come up with a good one. So that is what the problem statement. So problem, how you have to define a problem statement in our own way is identifying the problem statement by knowing what inputs and how you are going to process by using a different techniques, and what is the outcome. Okay, so what is the output of the particular your research work. So these three points are very important when you are defining a problem statement or the defining your own problem. Okay, because someone is reading your, understanding your problem statement means, for example, write a C program to generate Fibonacci series. It is a problem statement. So their series will be there. Okay, like that statement itself will, once you understand, then again we can go for many things. That is very clear here. Then again, objectives. So with the inline of problem statement, we need to define objectives. So what is objective? It is like a milestone. So in the research problem you have defined, I want to do this, that. So objectives are nothing but one stage to reach the particular problem statement. Okay. So here the main important in the research, the objective we should consider is, it should be very clear. Clarity should be there. So even similarly in the research paper also, whichever the research paper we are referring, we need to understand clarity of the what they wanted to, they are contributing. Then specificity, then specifically whether they have considered the one domain. Okay, IoT, in IoT only what they are doing, specificity. Then again, measurability. Measurability means what, how long the results they have achieved, whether it is measurable or not. Simply they have given statement like 100% achieved or 0% achieved or not achieved, only theoretical, no speaking. Practically measurability, it should be measurable. Then realistic, it should be realistic. It should be realistic, means should not say the false statement. What he obtained the results, he should be showcased in the paper. Okay, some of the papers you have downloaded from the local journal, no, like UGC or non-UGC paper, they don't have any results. That is realistic, they are not maintained. Then again, time bond, whether to write a particular paper, how much time they have taken, or research implementation, or PhD, or the PG, or whatever, time how much taken, that is also important. Shorter the time, means longer the time, good one, but also the time should be maintained. Relevancy in the particular domain, you are reading a particular paper, whether relevancy is same or different, outcome. Okay, so whether it is different or not, if you are reading, or he has defined the problem statement in understanding the image, at the end he has given us different statement, that is relevancy should be maintained. Okay, like that. Objective. Then overview of the system also you need to understand in the paper. Exactly in the overview you will come to know, okay, these are the block diagram. Okay, he wanted to do this, that, database consideration, result, pre-processing, segmentation with respect to image. Okay, so overall you will get an idea. So in the past too also I have said to go through this diagram, because diagrammatic representation you will understand some different. Okay, so then methodology. So what type of methodology? So in the paper, even after reading the paper, you will come to know what method they are used. Like methodology, here method used to solve the problem. What type of methods they have used? Whether it's SVM method or ENN method or any other method they have used. Then these are the questions you have to raise. That means he has raised the one paper which you are referring. No, the researcher he's read this question and he come up with a statement. Okay. So again, number of module structure design. So in that paper we need to come up with how many modules he has designed. Then again, database creation. What database? Whether he designed his own database or he has taken ready-made database or website, or which website, whether it is standard or not. How he is represented using gear diagram. Sequence diagram will be there. Activity diagram will be there. Okay, how they have mapped. Also, we need to understand. Then again, considerations. After understanding this, how the database you have considered for your own work, because someone is referred the database, someone has created database, you are not directly using, because he has created a database for his own work. So how to use, then you have to consider here. Then again, data flow diagram is clear that so what they have, how they have processed the particular the data. Then again, moving to the one more step is mathematical modeling. So mathematical modeling is nothing but here, as I shown here is we are going to construct one modeling with the help of mathematical operation, mathematical equations. Okay, so this thing is very important. Every researcher, especially even in the software, mathematical modeling is required. Even in other than software also, everyone is using mathematics. Okay, so here mathematical modeling is nothing but what? It is basically for three important operations. One is constructing, one more is solving, one more is interpretation. So we are considering one real-time problem and we are applying the mathematics, and again with the help of mathematical notation we are going to solve and we are going to give a solution to the external world. Need not to implement. In mathematical modeling, you will clearly understand that you have taken this statement, you are using, these are the mathematical equations and desired results. Okay, it's a conceptual way of representing. Okay, see here example, in the real world problem you are taken and you are getting the real world problem you are considered, you are receiving the real world solution. In between this, we have to refer mathematical world, that is called mathematical problem. Mathematically we have to represent, makes the assumption, set of assumptions will be there, and we need to identify or the construct the models or equation or the graphs. Then again, interpret the solution or the results in the form of data with a representation, and the real world solution will get, and this is ends the a complete problem. Okay, this is a mathematically how we are going to solve. After this mathematical modeling, we have to go for implementation. Then implementation will get the desired results. Okay, so this is very clear everywhere. The mathematical modeling is very important in the designing. Then implementation evaluation system, in that particular section in the paper, you need to understand here. So here two things are there. The first one is evaluation, or the approach or methods, and one more is data and the informations how they are represented. So in the evaluation, what we have to do is how they have evaluated, what language they have used. Okay, programming language, operating system, hardware, any software they have used. Okay, that also we need to identify. The next one is algorithm implemented. So which algorithm they have referred for their work. Okay, that may be SVM, ML, machine learning model, etc. Then technique used for pre-processing. Okay, normalization, segmentation, classification, prediction, recognition. It differ from the domain to domain. Okay, if you are a particular one domain, which are the techniques, different steps are there. In each step, whether they have defined their own program or tool they have used ready-made, then you need to understand in that paper. Then again, which model is used for database training? Because if the domain itself is dependent on the database, which database they have used, how they are represented also we need to understand. Then this is implementation part. In the implementation, how they have implemented, we come to know. Then moving to here, result and discussion section in the paper, we need to understand here, analyze the database considered, what type of database they have considered, identify the table wise training and testing samples, how many samples they have considered for training and testing, also we need to understand. So set of 100 or 200 or 1000 of samples they have considered for the database, testing 10 or 15 they have considered, like that we need to understand. And also we need to understand here, very important in the result discussion is analysis of the processing time and the accuracy also we need to understand. So processing time means what? Whichever the sample they have considered, whether they have obtained very quick results, processing time, how much time it will take to process, we need to understand. Also recognize that whether the appropriate results achieved or not. Based on these two parameters, we can say that accuracy of the system is 98, 95. Okay, that is also we have to understand. Then here, scope of the research work in the paper, we need to understand where is the scope in this paper. After see, someone has written, you are reading, but in that paper, what is the contribution to the society? That is scope also you need to understand. So this is related to the medical domain. This is related to the image compression. So image compression for the database redundancy avoiding, like that you have to understand. Feature scope. Okay, so identify the feature enhancement. So there may be a problem of database consideration, maybe is less number, our processing time is low, our recognition rate is also low. So we can proceed for improving that also. You can say betterment, better improvement of the system recognition, and how to achieve the accuracy of the system. These things we need to understand from the paper. Okay, so this thing will be there, we need to identify. So at the end of this session, I'm going to give some of the key points. Those key points you just remember and you just go through, read it, then you just catch it and just write it. Okay, that is what we have to do this in the research article. Then again, in the conclusion, in the paper, see, I am explaining in the paper what is their content, same thing. Conclusion part, when you reach to conclusion, is nothing but exhaust. Almost all researcher exhaust to do work, and then he has written, oh, I come up with this, that result, this much. That you have to see. Suggestion, expected, expanded, and improved things are added in the paper. You need to understand limitation of the study and their implication. Implication, as I said, no outcome, whether outcome is achieved or not, they have written these things from the conclusion. Okay, so some reference paper, what you have to see here is, if they referred good paper like IEEE, Springer, elsewhere paper, what type of paper, how many papers they have referred, that also matters. If you are one paper will be there, let us see, Springer paper, if you refer, no, all the reference paper are Springer only, elsewhere paper all elsewhere, only 20% will be other journal. Okay, like that you need to understand in that paper. Oh, okay, in future also, while writing a research paper, I should use only, when you are applying for elsewhere journal, no, you should have a minimum out of 100% reference paper. For example, 25 paper you planning to include in reference, you should use 20 paper in the which are related to the elsewhere, because they will see. Okay, so like that, it should be latest one. It may be, if you are in 2024 you are writing, it should be 23, 22 maximum. I suggest 23 is a maximum. Okay, so those paper only you have to, because latest work you are analyzing the gap, like that you have to go through it. So before writing research paper, we have to ensure these are the things, like domain of interest you need to understand here, as I said, which domain you wanted to proceed. Next one is to overcome the issue identified in the literature survey. In literature survey, we come to know that, so 5 papers, there are some gaps I am taking. Okay, then do your research work, plan for this, setup, implement it using Python or any other language which you have comfortable. You just get the results, and then get the desired result of the research work. Do implementation, get the results. After that, you start writing the papers. This is what you have to ensure. Some of the researcher, what they will do, especially research scholar or the PG students, what they will do, writing means they will start taking from the other and they start writing. It will not have paper. Okay, you will try to submit to the good journal, they will immediately first page only it will reject it. Okay, like that you have to go through it. So now this is all about the how to read the paper. These are the content will be there. Now I am moving to the article summary content. So from that particular one paper, what are the important content you should read it. Let content. There are three important points they have given, the coordinator has given as per the AICTE guideline. The first one is key principle. So particular one paper, as the case study paper is uh, Internet of Application and Opportunity and Threats. This is the paper we have taken, case study. So among the participant, sir, among the participants, 6 member, one team. Okay, so everyone should take the particular the papers. Sir, please circulate this paper. Okay, sir, but writing, I require, sir, 1.5 hours for only writing how to write the paper. This is reading is over, everyone knows this, that somehow they will read it, but writing is again art. Okay, so in the writings, again, as a key principle we need to understand. In key principle, there are some points are there, I am going to highlight. Then application of principles, in this particular points we need to find out some of the important points. Then key takeaway, exactly what are the important the points we have to take up from the paper. In the key principle, first point, these are the point you have to extract. The first point, key principle, we need to understand what is the aim of the paper. Next one is what are the objectives. See, I am telling, you are referring one paper. In that paper you need to identify the aim, objectives literature review perform. So literature review perform means how many paper he referred, what are the quality of paper, what are the issues. Then gap analysis. Okay. Then second point is application of principles. So in that paper, what are the important principles are there? Methodology proposed, because he has identified aim. Methodology proposed. What are the methodologies he used? Database or the data set creation representation. If it is related to the implementation paper, we need to define the database. If it is only review, no database, then you can write any, not applicable. And result and discussion, what result they have achieved, especially what we have taken one case study paper, no, in that result is not there, only technical discussion, because IoT and its opportunity and threats will be there. Then again, scope of the system. Okay, so these points we should consider in the second point. Third point, that is the final point, key takeaway from the article, conclusion. As I said, conclusion is nothing but exhaust. Researcher exhausted, he has written these, that I have done these, that also we need to issue of the paper. So from that particular paper, see, every research, every paper end up with some issues. That is what the art will be there. We need to understand why you are referring. See, suppose PhD or PG scholar, they wanted to do some research work, their guide will insist to refer the research paper, right? Why they are referring? To know the current field. So to know the current field, we need to understand the issues of the paper, issues of the research work. Then again, further study. Further study very clearly says that it is the two things will be there. One is database upgradation or database lack of database, as well as one more is the system computation, maybe in terms of processing time, in terms of recognition, in terms of accuracy. So that is what the further study we need to understand. Okay. So see, in the tomorrow class, sir, please, this is the case study will be there. In this case study paper, you just take it and you need to find out these three key. Okay. So in that particular paper, at the end of the page, they have given a one sheet. Okay, same points they have given. Okay. So aim, some gap will be there. So based on what I have explained today, aim, you try to read the particular this one, abstract you read it, introduction read it, you will come to know what is, see, you just feel it. Okay, see, as I said, no, it is the art of understanding the other researcher work. We are in right now in KLECET, right now rural place, where a researcher of this paper is from foreigner he has written. Okay, so his work we wanted to understand.
As per the FDP guidelines, we must have one team assignment. So there we must carry the article discussion summary, which is of 2 page. Template is already there with us. So there is a 13 page article. So that you have to go through and you have to carry the points what sir has already covered, like key principles or practices from the article. There are 3 to 4 bullet lines that you must carry. Then after to that, there will be an application of principles or practices in your function. So there, sir, was included the points like methodology proposed, data set considered, results and discussion, and scope of the system. Likewise, key takeaways. There again, we are having 3 bullet points: conclusion, issues of the paper, and the further study. So this one you must carry in a team fashion. So for the same, we would like to request you people to have a formation of a team consisting 6 members per team. So right now we are having a very less number of participants. Yes, sir. Then we are having as per our calculation, so we should form 8 teams. Per team 6 members, so 48 members. So likewise.
Sir, better my suggestion is from rule number as per the order 1 to 8, 1 to 7 one group, again 8 to 14, like that.
Yes, sir. What? Yes, yes, sir. We only will form the teams by looking to your registration.
See, sir, one more thing I wanted to give a instruction. 1 to 7 member, what you have to do is just go through these points. Already those points are there in the last page. Just aim, how to read paper, how to, you just write down the aim. Okay, so every scholars or the every staff, you are come up with a different information from the paper. No problem, but try to understand the aim, methodology, what the points they have mentioned. No, so just go
That,
through it.
second
Because I have prepared from myself. So tomorrow I am going to explain in detail what I have covered, exactly what the AICTE required. These points, no, I have written 2-page information will be there. At the end, I'll share you. From you also, today reading I have explained. Okay, based on this explanation, you just do homework and go through it and write it. This will definitely help you in the future. If you are writing your own paper, reading is important, no? I don't have any reading habit of paper. Start writing. Suppose among you, maybe someone is doing PhD or someone is trying for PhD. Your guide immediately suggests, hey, write one paper and come communicate to the conference or the journal. Then what you will do? You will search or you will ask no. So this will help. So how to read? So from that paper, what are the key points to be extract? That very importantly I have prepared. So tomorrow I am going to discuss in detail. So exactly in the paper what there. So my suggestion is you just go through individual, read it and come up with your own points. So one group 7 members are there, no? At least one key points 4 will be there. 4 into 3, 12 are there. 12 means 7 member. Somehow you adjust 1 or 2, 1 or 3. You write, come with the information. So tomorrow we will discuss among the group 1 or 2 papers. I will discuss remaining things what I have prepared. Also I will explain. After that, I want minimum 1 or 1.5 hour to explain how to write your own paper. That is a very important. Reading part over, then again writing. So very important in the article discussion is how to read is important. After that, writing. Before writing, what important key points we have taken, that is important. Okay, this ends the complete independence to the scholars or the PG students or the UG students to they can start writing their own paper. This is what my the motto in this article discussion.
This connection,
Okay,
what we request you people is please try to have your own team then. We want to give that liberty to you. So you only form a 6 members a team. And tomorrow morning session will distribute all these articles with the templates with you. That you can submit in the second session of this article discussion. No, madam. As per that guidelines, so we must have a signature also. So we need it in hard copy. Yes. We will post that complete journal in the group what we found already. Yes.
Sir, otherwise, sir,
Even
hard
will
copy
share the template also. You can just have a recall over that. And tomorrow we'll try to get the contents from you people. That will be better. So anyway, it is the first part of the article discussion.
Sir, otherwise you can circulate now only, sir. Whoever are there, no. Sir, better 1 to 7 group you just announce it in the WhatsApp group only, sir. Those are not there,
I will
no.
share this soft copy in their WhatsApp.
Soft copy also better, sir. If they want hard copy, you can give it to them.
Suprit, what you can take the remaining papers.
Soft copy also you can refer.
We'll share the soft copy.
Yes, sir. Yes, sir. Thank you.
Yes, thank you all for attending the sessions today, brainstorming session. Thank you, sir, for your informative session. Again, we will be having the